We're on page 30, and what we're looking at now is probabilities from the two tails of the curve. So we've got our example about our backpack, and we have our mean of 3.3 kilos, our standard deviation of 0.3, and we're now looking at the probability that a backpack weighs less than 2.8 kilos. Now here's a keyword, or more than 3.6 kilos. So if we think back to our rules about all probabilities, our all probabilities mean that we have to add the probabilities together. So let's draw this up. So we've got our normal distribution, and in this case mean of 3.3 with a standard deviation of 0.3. And it's talking about a backpack weighing less than 2.8 kg. So 2.8 kg is below that mean, so I'm just going to put it there. And it's weighing less than. So weighing less than means the value's below that point. Or we're told it weighs more than 3.6 kilos. So 3.6 is above the mean, so I'm just going to put it about there. And we want to say more than, so we're shading in the area above it. So you can see there we've got the two tails that are shaded in. So that's what we're trying to find. So we need to find the equivalent Z distribution with our mean of 0, and we need to find both the value below, that's equivalent to the x value of 2.8, and the value above, which is equivalent to the x value of 3.6 kilos. So let's do those calculations. So Z equals x take away mean over the standard deviation, and we'll do the first one, so that's our 2.8 kilos, so we're going to 2.8 take away the mean of 3.3 over our standard deviation of 0.3, and that is going to give us a Z value of negative 1.667. Okay, and take a note that I've rounded that to 3 decimal places because our probability tables go to 3 decimal places. So that means I can now replace that value there and say I want the Z value of negative 1.667, and I'm going to want the tail area below there. Then we'll find our other Z value, so I'm just going to call this Z2. And again, x take away the mean over our standard deviation. So this time the x value is that 3.6. Take away 3.3 over our standard deviation of 0.3. And that is going to give us a Z value of 1. So that tells me that I can replace that question mark that I had there, and I can put now the Z value of 1 in place, and I want to find the probability of the tail above that point. So what we need to do is we need to find this tail value, and then we're going to add that tail value, the probability of that tail, to this tail. So we're going to add those two probabilities together. So now we've got to find each of those two probabilities. So starting with our negative, okay, so there's our mean of 0, now on negative 1.667. So to find that area there, I've got to remember that that is the same area and the same probability as if I find a value of 1.667, the positive value, and look at the area above it. Okay, so those two areas, the positive and negative areas, will be the same. They're both talking about the tail with the same Z value, just one is below and the other is above the mean. So our probability tables are going to give us between 0 and 1.667. They are going, if you look at the graph on it, it's going to shade in here. This is the area that will find for us. Okay, so then we've got to bear in mind that the whole area on the left-hand side, sorry, the right-hand side, that whole area, if I shade in all of this area, okay, including the tail, that whole area there would have a probability of 0.5. So I need to be able to find, change colours, to find this area here. That's what I'm going to get from my tables. And when I look that value up on our probability tables, it tells us that that probability is 0.4523. So then, to find the little tail itself that we're interested in, if I want, then I've got to, so the probability of x being greater than 1.667, which is also the same as x being less than negative 1.667. That probability is 0.5, take away 0.4523, and that gives us a value of 0.04. Oh, let me just undo that to get it tidy. 0.0477. So that's how big that little tail area that we're trying to find there is. Okay, so that's one of the tails. Now we need to find the other tail. So our other tail, if I just start again, no, not that. Our other tail refers to our mean of 0, and had a standard z value of 1, and we were trying to find the tail above that point. So equally, we know the whole area on above the mean is a value of 0.5, and so we want to look up the table, and when we look up the table, we're going to find this area that I'm just shading in now. So that's what the table will do, is tell us how big that space is. And when we look that up on the Z tables, it'll give us a value of 0.3413. So then we can say, right, the probability that Z is bigger than 1 is equal to 0.5 take away 0.3413. And when we subtract those two, we get 0.1587. So that has found how big that little tail there are. So now let's put all of that information together. So remember, what we were trying to find is our backpacks with our mean of 3.3, and we were looking for lower than 2.8, so that area all below, or the area above 3.6 kg. So if I was going to write this out, I'd say probability of being between, of our x distribution being between 2.8 and 3.6, and that is equal to the probability for our z values that we found of negative 1.667 up to a value of 1, and then that's equal to those two tails that we found. So if I just flick back a moment to those two tails, so we found that one tail had this value of 0.0477, and because it's an all probability, we're going to add that with the probability we just found previously of 0.1587. And together, that gives us a probability of 0.2064. And this is probably the most complicated standard normal distribution ones that I've probably ever seen. So this should be as hard as it gets.